Video tutorial on theory assignment number 1, which is intervals. Specifically, I'm going to cover the theory and construction of how to write them and how to read them using musical notation. I'll try and keep this video as brief and concise as I can. I'm going to break it up into 3 parts, and you can always go back and review any one of the sections that you didn't understand or need clarification on. So here we go. How did people come up with this? Well, about 2,500 years ago, the mathematician Pythagoras, who you've heard of before, so if you're wondering how algebra and physics and music are related, here you go. Pythagoras was trying to figure out how string and wind instruments were producing the sounds or frequencies that they were producing, and how certain ones people seem to like better than others. So what he did is he assigned ratios to them, and when the note was the same, it's a simple ratio, 1 to 1. When it produced frequency or pitch that was an octave higher, 2 to 1. This one right here in the middle, 3 to 2, pleasant sound, this is the perfect fifth, and 4 to 3, or the perfect fourth. And I wrote those out for you here. These particular sounds also occur in nature, and they are what's called the Overtone Series or the harmonic series, and they're the bottom part of that. You can always look that up separately if you're curious about how that goes. So the perfect intervals that are labeled here are the most consonant or most pleasant sounding basically that people like, and they're the most common intervals that you hear in music, Western music today. Perfect unison, perfect octave, perfect fifth, perfect fourth. If I continue on sounds that are a little bit less consonant or have a little bit more attention to them, there's these ratios here that are predominant in a scale that we use that you know called the major scale. It's the major second, major third, sixth, and seventh. If I take the top note here and I lower it by a half step, you get the minor intervals. So the minor second, minor third, minor sixth, minor seventh, which have a sound that is more dissonant or less consonant. You're going to notice that there's some color coding here to explain really quick, and that's because each of these intervals kind of has their pair or their inverse. So the opposite of a perfect fifth is a perfect fourth. So if I write a perfect fourth below or a perfect fifth above, it's going to be the same pitch. Seconds and sevenths are pairs, and third and sixths are pairs. The fourth and fifths are the ones that sound nicest or more consonant, then thirds and sixths, and then seconds and sevenths sound more dissonant. And then there's this one. In between the perfect intervals, down here I am at the keyboard, I have going to a perfect fourth, which would be an F, and a perfect fifth, a G. There's a note between that, which is either a G flat or an F sharp. Looks different, same thing. And that sound right here is a very dissonant sound, and it's known as either the diminished fifth, when you lower that perfect interval, or the augmented fourth, when you augment or raise that perfect interval. It's also called the tritone. And the sound there is a very dissonant sound right in between. If I take all of these all together and put them all together within an octave, the first and the last note, I'm going to get 12 of them, right? And the 12 ratios that are between it is what produces the chromatic scale. These are all the intervals that we need within an octave. When I write it in musical notation and go up, you'll see sharps. When I go down, it'll sound exactly the same. It's just written differently to notate that you're lowering the pitch, and you're going to see flats. Oops. Okay, so with all of this, let's go to your homework. How do I visualize an interval? So the first part of the interval, or the homework, is pretty simple. All you're being asked to do is on musical notation, when I read music and I look at a musical staff, how to identify or write a note that is a second, a third, a seventh, whatever, above. And all you need to do is really count lines and spaces. So starting from C, which is on this third space, if I needed something below it, what's a third below this? I'm going to count space, line, space. Yeah, you'll notice that all thirds are either space to space or line to line. and that's it. If I choose to do an ascending interval, let's say I want to do this seventh above, I'm going to start with the space below here, and I'm going to go space, line, space, line, space, line, space. I can also just count on my hands or in your mind. You can just count 7 notes above, starting with the first one, and that's what it will look like when you write it in musical notation. And that's it for part 2. So then we get to the last section, which is part 3, which is with all this information, how do I put all of these major and minor and diminished intervals exactly the way that they are on musical notation? I'm going to present 2 ways to do it, and whichever works for you, great. The first way is right here. It's mathematical, it's very sequential, and you just need an answer key. Here's the answer key right here. A perfect fifth above C. So if I want to create an interval above or below any given pitch, and I know where the notes are in the piano, all I have to do is look at my key here. A perfect fifth is 7 semitones or half steps above this. So all I have to do, here's my C, is I just count using the piano. 1, 2, 3, 4, 5, 6, 7. It should be right here. And there it is, right? Let's go to the next one. I want a major third above the note D. It says here that a major third above D is 4 semitones or half steps. Okay, 1, 2, 3, 4. And there it is. And that's really all it is for that system. So you can use this knowledge of the piano here. You could just count intervals in your head, but it needs to be sure. Remember, this can't be like G flat. It has to be F sharp. Why? Because it said a third. And so a third is 4 semitones or half steps. 1, 2, 3, 4. Yeah? And it wants a type of third, not a type of fourth. And that's how that is created. There's one more way that you can do this if you prefer this method. And this method is especially useful if you know the circle of fifths. So if you know the circle of fifths, you know how to create a major scale using flats and sharps. Okay, so here I have written for you the D scale. And if you know your circle of fifths, you know that the D scale has 2 sharps, F sharp and C sharp. If you can play this particular scale on your instrument, then you can figure out all of the intervals that you ever need. Here they are written for you. So let's say I start at D, and I want to know what a major seventh above D is. Well, it's the next to last note of the scale, 7 notes above, and you already know that it's C sharp. That's it. That's all you have to do. Okay? If you're looking for these major intervals, and I can transpose this or try this. Let's put it on F, for example. You know that the F scale has 1 flat in it because you've played it before. So if somebody asks what's a perfect fourth above F, you take the first note, do your scale, and you know that 4 notes above the F scale is B flat. That must be a perfect fourth. So that solves everything, except for what happens if you have a minor interval. What if they wanted to know what a minor third above F was? What do? Well, simple. Since it's just 1/2 step lower, you just lower the A 1/2 step, which is right here, which happens to be A flat, right? It can't be G sharp because that would be a type of second. That would be 2 notes and then an augmented second above, which we're not dealing with that now. We're dealing with 3 notes above. So again, what would be a minor seventh above F? Here it is. I go up my scale, I take the 7th note, I lower it a 1/2 step, and there I go. Last one was our tricky interval. If I were to take this and I were to say, what is an augmented fourth? Above here, well, instead of B natural, or B flat, I would just go to B natural. Or if you want, you can just leave it as B, the regular note, if you're writing it. And that's it. I hope this was useful to you.